Good morning. I'm Tim Rossiter. I'm Core Network Architect for Sky Broadband, generally concerned with the themes of capacity planning and structuring the network to deliver that capacity efficiently. And I'm going to talk about basically how we've developed the network in the context of the whole UK broadband usage and pricing development over the last 10 or 20 years, really. How our own network structure has evolved, and in particular the recent capacity upgrade we've started and just about to conclude, and finally how we localise content delivery to make more efficient use of the network. So, right, these slides aren't working with their animations. It probably would help me if that were, yeah. Sorry. Still on my thunder. Okay, yeah. Oh, that's interesting. Well, different font anyway. Yeah, so this is using the Ofcom International Communication Market Reports. This shows how traffic has grown in developed European countries, and the US is the brown line, Sweden's the purple line, Korea's the black line. Steady growth, US 20% year on year. Where does the UK fit in on that? Well, that's good old Blighty, starting with PAC and soaring ahead. And it's quite extraordinary, really, that we haven't got international figures for 2017, but we have got UK figures for 2017. That's the consumption per line, 190 gigabits per month per line, which appears to pretty well be the highest in the world, which is pretty amazing given that we've got basically a copper line infrastructure. Clearly the copper line infrastructure is not an inhibitor of usage. So that's good news for the people using the network. It presents a capacity problem for the people supplying it, common to Sky and most UK operators. We saw the huge surge that you see in 2015, 2016, a little bit earlier with the deployment of the catch-up on the Sky set-top boxes. So that's our traffic level. Back in 2008-9, when I joined Sky, we were about 100 gigabits total served. We're now at close on 8,000 gigabits and going on to 15,000, 20,000 in the next few years. So over 10 years, we've seen a 100-fold increase in total network traffic. That's been accompanied by subscriber growth. So the per sub traffic has increased by about 30%, 38% year on year, which actually is consistent with the with the Cisco forecasts. It's easier to see what's going on a logarithmic scale, and I'll show that graph a number of times as against successive net upgrades. The kink, which you see sort of 2014-15, really, there's two reasons for that. One, UK market sort of started to saturate in the number of subscribers, so the subscriber growth leveled off. And also, we actually saw a very high growth prior to that when the set-top boxes were rolled out, and the growth has moved, still quite considerable, but a bit more manageable, thank heavens. What about prices? Well, this is, I sort of dug up some old stats to see what the UK price trend has been. Back in the mid-90s, you would dial up at 56k, and you probably paid about £30 for your phone line and £10 or £20 for your dial-up costs. That probably was about £80 or £90 in today's money. DSL started run about 2,000. Speed went up by a factor of 10. Price still 30, 40, £50 a month. ADSL up to 5, 8 megabits. Another times 10 increase in speed. Again, the same price. And VDSL and the Virgin Media cable offerings take you up to 50, 100, 200 megabits. Again, for 30, 40, £50 a month. So really, the subscriber has paid the same monthly charge for his line, same revenue for the operator, and he's got a times 1,000 increase in available capacity. The data rates actually have, if we look in the last 12 years, which is probably from DSL, which is what really matters, it's gone up by a factor of 100. So we've seen the cost per bit reducing by 67% year on year, and huge capacity increase. That presents a challenge for the operators. So what does the Sky, just a bit of background on what the Sky network looks like. That's our core network. It's quite a concentrated network. We've got 4 supercore locations, 2 in London and the top 2 in Birmingham and Leeds, and within each we've got double routers. It's a sort of a 2-ring structure. It's basically operates in a load sharing manner. Keeping it simple makes it very easy to do upgrades and changes, but it also has the downside that it's a very concentrated network, and we tend to run out of capacity on our core routers a bit earlier than you might otherwise if you had more super nodes. So, how does the traffic get out to the subscribers? We've got about 60 points of presence around the country, some obviously the 4 in the main supercore nodes, but also in remote locations, such as places Cambridge, Gloucester, large cities. And then that goes out to about 3,000 local exchanges, which either get to the subscriber on our own DSL lines, or more and more nowadays with a GEA interconnect into BT OpenReach for their FTTC network. So the DSL will be there for a long time, but clearly VDSL gives you higher capacity, which we're making use of. Traffic gets onto the network through peering and transit, and where we connect to both transit providers and also a lot of peering providers, mainly CDNs. That only supplies about 30-35% of our traffic. I'm afraid I've obviously bored one of the younger members already. The other way we get a lot of traffic is with CDN, either from remote locations or from the POPs, and I'll say a bit more. I'll say quite a lot about that later. So that's how traffic gets on and off the network, and that's what we have to work with. We've got a fairly strict resilience policy of dual feeding everything, dual PNT sites, multiple CDNs. We dimension to withstand one single major failure, and a major failure is the loss of one entire supercore site or fibre, which could be 80 times 100 gig links. So it's a pretty major capacity loss we plan against. The consequence of this is it turns out to be quite an easy equation, really. It turns out that the largest router capacity we need at any node is about equal to the traffic we're serving. So if you're serving 8 terabits of traffic, you need an 8 terabit router, which makes the next slide a bit easier. So we started in 2005 with Cisco CRS-1, which was, for its time, a big router, 40 gigabits per slot, 640 gigs per chassis. And that's where it looked. So that started us. We had a lot of capacity for the first 5 or 6 years, which was nice. We didn't have to worry about that. And took us through to around about 2011. At that point, Cisco kindly delivered the CRS-3, which was basically a fabric and line card upgrade, which took us to just over 2 terabits per chassis, a 3.5 times increase in capacity. And that did us for about another 2 or 3 years, not very long. 2014, we had to replace the CRS. That really had reached the end of its capacity growth with a new router. We chose the Cisco NCS 6008. It's a new chassis, a forklift upgrade. Network traffic was about 2 terabits, and it did 8 terabits per chassis, 12.5 times the original capacity. That we thought was going to do us for about 3, 4, 5 years. It didn't work out that way. 2017-18, we were again starting to hit, we could see we were going to hit the end stops on the NCS 6000, and our plan had been to upgrade that to a back-to-back chassis with higher capacity fabric, but that came along a little bit later than we really wanted. So we went out and looked for a new node and chose the Cisco NCS 5516, which gave us a huge increase. It takes about 55 terabits per chassis, as you see way up there. So that really should do us for quite a while. The last thing was we still had the NCS 6Ks, which are very new routers with a good upgrade option. So we've reused the ones we're taking out of service in a back-to-back configuration, which I'll show later. So just about the router, that's what we bought a couple of years ago. It's a bit of a beast. 8 terabits going into those 8 line cards at the bottom with a good roadmap. This is the new one we've got, the NCS 5516. The reason I've shown that photograph really is because those 2 slots, that's our lab router. which is sort of small configuration. So we've populated 2 slots, and those 2 slots take almost the entire capacity of the 6,000 router. That's some indication of how things have moved forward in the last, just in a matter of 3 years. That's partly achieved because the 5500 has somewhat lower functionality, but it's ideally suited for our core function of a P router. I'm running on time. Oh, and that's just out of interest, whilst I had a camera out, that's what the back-to-back configuration looks like. All these cables, you probably can't really see them, but there's almost 100 MPO cables there with, in fact, 1,000 fibre pairs used to link the 2 chassis together, which is quite a major undertaking, but it does work and works very well. And this is how optics have developed, and that I'll say a bit more about optics because that's quite important. So we started off with 100 gig with the CFP. We moved to the much more compact QSFP28, which has the advantage of being widely deployed in data centers and comes in at some very low cost points. Now, what does it look like? Well, that's a graph again of how the cost for the subscriber bandwidth has declined, and the brown arrow shows basically how the equipment cost, if you take into account the development in router silicon, slightly reduced functionality, move from long-range to short-range optics. If you use all that, you can just about match with your router infrastructure the cost decline of 10 to 1 in 6 years that you're getting basically on your income. If you don't use SR interfaces, as we can't everywhere, you do get a different trajectory, the blue line, which is starting to get more expensive. So by really working at honing our infrastructure, we've sort of got a good cost trajectory. I'll say just a little bit about how we migrated. When we brought in the NCS 6K, we had to upgrade everything in one go, just build a whole new ring. And we had to do that very fast because growth was very fast. This time we didn't have to do a big bang migration. We could do one node at a time, and we started with Birmingham. So the first thing was to drop the new router into the existing ring, just pass traffic through it, check it's all going and happy with it. Then gradually we start to swing both feeds and consumers over. So I've swung the core CDN and some POPs over. And this needed quite a lot of planning because that link from the old grey router on the left to the orange router on the right, that is there for protection traffic. It's not there to offload normal working traffic between nodes. So we had to manage the traffic capacities very carefully and do a fair bit of modelling to do that. And we sort of moved through several migration steps, step by step. It all went very smoothly, actually. And we ended up with all the feeds and consumers off the new router. Last stage is just to swing over the other supercore link onto the new router and disconnect the old router completely. And then that's the penultimate stage. And then finally, you move the old router and combine it with the existing router, which gives you so you're starting to build one ring with the very high capacity NCS 5K and keeping an old ring with double the capacity on the 6K in its back-to-back configuration, which just needed a fabric change to the back-to-back router. And it all worked out quite handily. The red arrows are roughly when each node exhausted in capacity. Those are our 4 main nodes, the 2 London nodes, Leeds and Birmingham. So Birmingham, we dropped in the new node, and then 3 months later we could upgrade the existing 6K router, and likewise with Leeds, and we're just doing our first London node. And rather handily, our second London node was the one we had to come to last, which was useful because it was the most complicated one to upgrade. It needed a chassis move. The other ones we could basically leave the old chassis where they were because you would have quite a long connection on the back-to-back connection. So that's all going very smoothly. That really has solved our capacity problem. The 5K ring should be sufficient for about 5 years. The remaining 6K ring will do 2 or 3 years, maybe 4 if we're lucky. At that point we can decide whether to replace it with the 5K router and its very low cost point, or whether to upgrade our 6Ks. So the router, as I've shown, the router, we've solved the capacity problem, we've got a price trend which we're happy with. Are there any problems? Well, yes, there are. Transponder price decrease has not moved at the same rate as the either the cost of providing bandwidth or the cost of to the consumer. I was involved in optical transmission back in the before the turn of the millennium, and 10 gig at that time seemed pretty complex. Now, in retrospect, it seems very easy. You just had to basically modulate a laser and do a bit of far-end error correction. Moving to 100 gig, where you're getting 100 gigabits down the same basically optical bandwidth as you used with 10 gigabits, is a huge degree of complication. There's QAM modulation. You've got two detectors because you've got a coherent system. You've got dual polarization, so two lasers and times two detectors again. Ultra high speed A to Ds and very high speed DSP and stronger FEC. So it's not surprising that optical transmission hasn't followed this sort of Moore's law trend, because to get to that higher, that times 10 capacity increase, you've had to pile in a lot more processing and a lot more optical hardware into your transponders. So distance, in comparison with routing, is becoming relatively more expensive. The consequence is you should localize your traffic sources. We've known that for a long time, but doing it turns out to be rather harder than we might think. So most traffic originates from CDN networks, either in large CDN providers like Limelight or on your own network, where Sky has had on-net CDN for quite a long time. So how can we localize this, and how much can be localized? And we run into some practicalities of the usual ones, diminishing returns and long tails and so on. First option, if you've got the CDN off-net, you don't have to pay for the space or the power, but you do pay in transmission, because your main route is going through a couple of transmission links, and then you've got all these protection options for an alternate source and going different ways across the network. So you're really providing a lot of transmission capacity, which, as we see, is becoming more expensive. So off-net CDN is looking less and less attractive. What we first did was we put our own CDNs into remote locations where we had power and space to power them, and that was a help, but it wasn't great because you still had the transmission links from the remote locations into the supercore nodes and then down to the POPs, and not huge economies there. Moving it to the supercore nodes cuts out all but one transmission link, so you've taken a lot of cost out of it, but you've now using up space in your supercore locations, where it's generally limited, expensive, and there are probably power restrictions because you've got things you'd rather put there. The obvious thing, and it's obvious to state, is move the CDN to the POPs, where you can serve the exchange links directly, and if it fails, you dimension some core CDN to give you a backup. And we can plan this fairly well. It works pretty efficiently. So that's what we've wanted to do for a very long time, but making it happen was quite hard. The last thing, oh yes, and if you've put your CDN at the POP, you can also serve other POPs, and your sort of backward transmission from the POP back into the core comes for free because of the highly asymmetric traffic flows within an ISP network. The last place you could conceive putting it, and we've been quite nice to, is to put it at the exchange. The problem is that the volume of traffic at the exchange is not really high enough for this to work in all but a very few large exchanges, and most exchanges, they're open reach locations with limited power and space, and also our own BNG architecture would have to be changed to do that. Final thing, it isn't really CDN, but it works in much the same way, is to most of our broadband customers will also have Sky set-top boxes, and you've got a 1 gigabit per second satellite channel coming into the set-top box, so you can use a little bit of it to pump down very popular programs onto this set-top box. We did this with with Game of Thrones, and it worked very effectively. A lot of people thought they were doing it on demand. In fact, they were playing what was already in their box, and it had no impact on the core network. So occasionally that works, but it's not a scalable solution. So how many places can you do this trick of putting the CDN at the POP? Trouble is, we haven't got one CDN. We've got multiple providers. There's 5 providers, and that's indicative of the kind of sizes. They tail off, and we've got POPs which start with 1 or 2 very large ones and then tail off. We've got 60. I've only shown 20 here. So if you do that at fairly low traffics, and you say, okay, for CDN to work, and bear in mind you need a high traffic to get effective cache efficiency, you want to have 10 gigabits of CDN traffic at each node. So the green cells are the POPs and provider intersections where you've managed to get sufficient capacity for that to work. 9 locations and 31% of your offloadable CDN has been localized. This is where we started, and in fact we rolled it out to more locations than were really warranted, and we served other POPs from it, and it got us going, helped a bit. When your traffic doubles, things look a bit better. You've now got 27 green cells, 27 CDN deployments, and you're covering almost 60% of the offloadable traffic, which is really quite a dent out of that traffic, which would otherwise have to be carried across the network. It does get a point of diminishing returns. If you double the traffic again, we now need 130% more deployments to 63 locations, but we've only bumped up 50% more traffic. And bear in mind, every time you deploy a CDN, you've got problems of finding space power and an ongoing maintenance issue. So probably that top model is the sweet point to have effective POP CDN deployment. So that's the theory. How did it work? Well, it's easy to see the benefits. We found it really very hard to realize them, and I was grateful for some excellent work done by my colleagues over an extended period of time to make this work. We have 5 CDN providers on net. Each has their own approach to localization. Thank you, I'm about on time actually. They either do it DNS, messing, HTTP redirect, and some of them have their own secret source where they sort of modify that as they think is best. And also, if you're going to you can't just localize some POPs. You have to specify mapping for them all. And we found this needed software upgrades to our BBPs to make it work effectively. That's where we started. So that's a 2.5-year period, really. The first 6 or 9 months, we basically put in the CDNs and let the providers do their own thing, because they ought to know a bit about localization. Well, the trouble is, if they're going to localize, you need to feed them a bit more information. So the next phase was starting to specify localization and mapping, which again we had to do in 5 different ways for the 5 different providers, and that took us up from 40% to the sort of high 80s in localization. And at that point we started to run into the last problems of we weren't quite doing things correctly in our BBPE configurations, and that was a fairly slow progress to roll that out to all the nodes. But we got there eventually, and we're now seeing about 90 or 98, 99% localization, and taking about 33% of our total subscriber demand basically off the network. So that's really made a very large saving in terms of the amount of network we need to provide. I did mention IPv6. That caused us a little problem, but at the same time as we were doing this, we were doing our IPv6 rollout, and it isn't really relevant to the talk, but just it's another little interesting story. We started quite early on in amongst the UK providers on IPv6. It was a bit slow at first, and then we did quite a major rollout, and we've now got about 95% of our customer equipment enabled for IPv6. There's a problem with some very old routers, and where customers have substituted their own router, which we can't upgrade. But we've basically done as much as we can on the subscriber side for IPv6, and we're now waiting for the providers to do their bit as well, which quite a lot of them are. So just to give a few acknowledgements, you can read them there. It's been a fantastic team at Sky. This has gone very smoothly, these upgrades, and I'm very grateful to a lot of hard work by my colleagues in doing this. So, thank you.
Thank you, Tim. Do we have any questions for Tim? Okay.
He works for me as well. Fantastic presentation. Thank you for sharing with us. So it was a very good presentation. Thank you for sharing with us. I had two questions. One, curious about what you do when you have a CDN failure. And how you cope with that, and does it really save you money? And then secondly, what wasn't clear was what's Sky traffic versus other people's traffic in terms of your own TV content, because I imagine that's probably a unique thing for you guys to some extent. And linked to that, your point about off-net CDN we really like that. I hope that means that Sky are developing an on-net CDN, because we would love to have one of them.
Yes. Okay. Failure. Well, that basically we work on the basis that you'll only get one failure at the same time. So if the CDN has failed, we hope, and the statistics say that one of the pop-up links shouldn't have failed as well. So if you've got both pop-up links working, you've got double capacity into the POP, and we dimension things such that that is sufficient. The mix of the different CDN providers, well, I don't have those numbers, and it's a bit confused because we get a lot of BBC iPlayer on the Sky boxes, which is served from Sky CDN, so it isn't quite as clear-cut as it might be. But there's no overwhelmingly large CDN provider. They're all, the top two or three are all at much the same level. And Sky's own on-net, well, we use commercial CDNs on-net to carry our content, which could be deployed within other networks as well. Yeah.
Tom Hill from Bytemark. Thank you very much for your presentation. I was just curious as regards the optic pricing between LR and SR and how it matched the decreasing cost of broadband trends, that trend that's going down. Did you evaluate optics away from your vendor, so third-party optics or something like that, and would that have made a difference to the LR price in terms of keeping with that trend?
Getting into commercial areas there. I mean, LR4, QSFP LR4 from the prices we've seen is a lot more expensive than SR4, and really starts to become a killer. So wherever possible, we've moved to SR4. We looked at one or two other vendors, and the deal wasn't really worth making the change. But we're always open to that. Yeah.
Can I go back on that? Oh, cheers. Just very quickly, I did wonder whether or not we would see you peering outside of London at some point in the near future, or whether or not CDNs have killed that off.
No, I mean that would be great actually, and I've wanted to peer in Manchester for a long time. Trouble is getting sufficient volume. I mean, I think we've been rather occupied with this core upgrade, and will be for the next couple of months. But I hope to look again at northern peering, and there's a lot going for that, because really, as we saw, Birmingham and Leeds are actually our largest nodes. So it would make a lot of sense to peer close to those. Yeah.
Okay, thank you.
Thank you.